Topic 3: Chemical properties of metals. Now, as you have studied the physical properties of metals and non-metals, the metals can be distinguished more from non-metals by studying the chemical properties. A simple activity has been shown that chemical properties should be studied to study more about metals and non-metals. You have studied earlier also that on burning the magnesium ribbon, a white ash is produced. Magnesium burns with a dazzling flame, and when this white ash is dissolved in water and tested with red litmus paper, it turns blue in color. Another activity by taking a non-metal can be performed, like sulfur is taken in a china dish, sulfur powder, and it is heated over a Bunsen burner. Some gas is evolved, and when this gas is collected by bringing a inverted test tube and then it is dissolved in water, it is found that it turns blue litmus to red in color. So, it is necessary to study the chemical properties of metals as well as non-metals to know more about metals and non-metals. So, now we will discuss the chemical properties of metals. What happens when metals are burnt in air? Now, different metals are taken and burnt in air, and it is found that different metals react with air differently. Some metals like sodium and potassium, they burn in air without heating only. When they are exposed to air, they will burn, whereas some other metals will react on heating strongly in air and form their oxides on reacting with oxygen present in air. So, a general equation can be written: metal react with oxygen present in air and form the metal oxides. We have studied in the previous chapter also that copper is a reddish brown powder. When it is heated in air, it forms black colored cupric oxide. So, equation can be written, a balanced chemical equation: 2Cu plus O2 gives 2CuO. Similarly, aluminium on heating in air forms aluminium oxide. Its formula is Al2O3. A balanced chemical equation is 4Al plus 3O2 gives 2Al2O3. Also, we have studied that metal oxides react with the acids and form salt and water. So, metal oxides behave as basic oxides or behave as bases and form salt and water. Now, there are certain oxides which on dissolving in water behave as acids also and bases also. So, some metals react with acids as well as bases and form salt and water. Such oxides are called amphoteric oxides. These oxides not only react with the acids, they also react with the bases and form salt and water. One example of amphoteric oxide is aluminium oxide. Al2O3 reacts with hydrochloric acid and forms aluminium chloride and water. So, balanced chemical equation is Al2O3 plus 6HCl gives 2AlCl3 plus 3H2O. Aluminium oxide also reacts with a base, that is sodium hydroxide, and it forms sodium aluminate 2NaAlO2. Now, balanced chemical equation is Al2O3 plus 2NaOH gives 2NaAlO2 plus H2O. So, these are certain examples of amphoteric oxides. Most metal oxides are insoluble in water. Some of the metal oxides dissolve in water and form alkalis like sodium oxide and potassium oxide. They react violently with water. and form sodium hydroxide and KOH, potassium hydroxide. So, these water soluble hydroxides are also called alkalis. Also, you must know that there is no need to heat sodium. It vigorously reacts with the oxygen present in air and forms because sodium as well as potassium react vigorously in air. So, when these metals are exposed in air, they will catch fire. That is why both sodium and potassium metals are kept immersed in kerosene oil, so that they do not come in contact with the oxygen present in air to avoid accidents. This precaution has to be taken, and also these metals, when they have to be used, they should not be touched with the hand. Now, also these metals like magnesium, aluminium, zinc and lead also continuously keep reacting with the oxygen present in air, and they get covered with a layer of their oxides. Now, this oxide layer protect these metals from further oxidation. The metal underneath does not further undergo oxidation. The oxide layer acts as a protective layer. Iron as such does not burn when heated, it will not burn, but if the iron fillings are sprinkled over the burning over the flame, it will burn. Copper does not burn. Silver and gold, they are very least reactive metals. They do not react with oxygen even at high temperature. Silver does not react with the oxygen present in air, even gold does not react with the oxygen present in air, and do not form oxides. Of course, silver jewelry, when it is exposed to air for a long time, it becomes black in color, but that is a sulphide it forms. It forms Ag2S, silver sulphide, on reacting with H2S gas, hydrogen sulphide gas present in air. Now, this property, just now we discussed that some of the metals react with the oxygen present in air and form an oxide layer which acts as a protective layer, and this property is used for making certain cooking utensils and some decorative pieces by the process of anodizing. Now, in anodizing, what is done? The aluminum metal is covered by aluminum oxide layer, which prevents it from further oxidation, which prevents it from corrosion, which prevents the metal underneath to react further. So, anodizing is done. How it is done? It is done by electrolysis. Aluminum substance, aluminum utensil or any aluminum object, may be a utensil or a decorative piece, to be coated with aluminum oxide layer is made anode. Any other metal is made cathode, and it is electrolyzed using dilute sulfuric acid. Oxygen gas will be liberated at anode, which will react with aluminum and cover it with the layer of aluminum oxide, which acts as a protective layer. This aluminum oxide layer can also be further dyed into different colors to make it more attractive. Thicker is the layer of aluminum oxide, protection will be more. So, by making the aluminum oxide layer thick, protection of aluminum objects can be done. So, let us discuss what is anodizing. Anodizing is a process of forming a thick layer of aluminum oxide, which prevents the metal underneath from further oxidation, or we can say from further corrosion. What happens when metals react with water? For this, an activity can be performed by taking various metals and observing their activity with water. It has been found that some of the metals react violently with water, producing a lot amount of heat, like sodium and potassium. It is a very violent reaction, and this reaction must be performed very, very carefully, because the reaction is so much exothermic. A lot of heat is evolved, due to which the hydrogen gas liberated catches fire immediately. Some metals react with cold water also, some metals react with hot water, and it has been found that some metals react with steam. So, let us see which are the metals react with cold water and how do the metals react. Metals react with water to form metal oxide and hydrogen gas is liberated. Now, these metal oxides further react with water and form metal hydroxides. So, this is a general chemical equation, and we are studying it, how do metals react with water. As I have told you right now that the metals like potassium and sodium are very reactive, and they react very violently with cold water and form hydroxide, potassium hydroxide and hydrogen gas is liberated, which catches fire immediately due to the heat evolved during the reaction, and same is the case with sodium metal. Calcium also reacts with cold water, but the reaction is not so violent. It forms calcium hydroxide and hydrogen gas is liberated. Magnesium does not react with cold water, it reacts with hot water and forms magnesium hydroxide and hydrogen gas. Now, in these two cases what happens, calcium and magnesium, they float over the surface of water, because the bubbles of hydrogen gas stick to the surface of these metals. They become light in weight and float over the surface of water. Now, some metals do not react with hot water also. Now, for those metals are like aluminium, iron and zinc. These metals react with steam. Like this, an activity can be performed in which these metals will react with steam. In a glass tube, the sample of the metal is taken, and this is the glass tube. Glass wool soaked in water is taken at one end of a dry glass tube, and it is heated with the help of a Bunsen burner. Steam will be formed which will react with the metal, and the gas liberated is collected over water, and this gas is hydrogen gas when it is tested by bringing a burning match stick which will burn with a pop sound. And this is glass trough which is filled with water. Okay. So, the metals which react with the steam are aluminium, iron and zinc. So, let us write the balanced chemical equation and see what happens. In all these cases also, as you can see from the activity, hydrogen gas is liberated. So, here metal sample can either be aluminium, iron or zinc. Aluminium reacts with water, steam, and it forms aluminium oxide and hydrogen gas is liberated. Same way, iron reacts with the steam and forms ferric oxide and hydrogen gas is liberated, and in the same manner zinc also forms zinc oxide and hydrogen gas is liberated. The metals like lead, copper, silver and gold do not react with water at all. Other property is the reaction of metals with acids. How do metals react with the acids? Now, we will see. For this also an activity can be performed by taking various metals and testing them with acids, dilute acids in the lab, and see how do these metals react with acids. Here also the metals like sodium and potassium react violently with the acids, dilute acids. The reaction must be performed very carefully because it is an exothermic reaction. Sodium, let us first discuss this general equation, the word equation. Metal plus dilute acid forms salt and hydrogen gas. And now let us see what happens with dilute HCl. How do these metals react, like sodium, magnesium, aluminium, zinc, iron and copper. As I have told you earlier, sodium reacts violently and it forms salt, sodium chloride and hydrogen gas. Magnesium reacts with hydrochloric acid and forms the salt, magnesium chloride and hydrogen gas. Aluminium reacts with hydrochloric acid and forms. Now, you can yourself write the equations, try to complete the equations yourself. So, in this case what will be formed? Think over it and write it. Aluminium chloride will be formed. Now, think what will be formed in this? In this case zinc chloride will be formed, ZnCl2 and hydrogen. In the case of iron, write the equation yourself. Ferrous chloride and hydrogen will be formed. Now, let us see what happens in the case of copper. Copper is very less reactive and it does not react with HCl and it forms nothing, no reaction occurs. In the same manner, you can write these equations of the various metals with sulfuric acid yourself. In the same manner, various salts will be formed and hydrogen gas will be liberated. Nitric acid, most of the metals do not react with nitric acid because nitric acid is a very strong oxidizing agent. It oxidizes the hydrogen gas liberated to water and nitric acid itself gets reduced to the oxides of nitrogen like dinitrogen oxide N2O, nitric oxide NO and nitrogen dioxide NO2. So, hydrogen gas is not liberated in the case of nitric acid on reacting with metals. So, metals normally do not react in fact with nitric acid and do not liberate hydrogen gas. But the metals like manganese and magnesium react with very dilute nitric acid and forms the salt and hydrogen gas is liberated. So, manganese on reacting with nitric acid forms manganese nitrate. So, think about the salt which the formula, what should be the formula? You can yourself write manganese nitrate and hydrogen gas. And in the case of magnesium, magnesium nitrate. Now, think about the formula of magnesium nitrate and write it down. Copper does not react with any of the dilute acids, as we have discussed earlier in the case of HCl, in the case of H2SO4 also, in the case of HNO3 also, it does not react with the dilute acids. Other metals also, silver, gold, lead also do not react with the dilute acids. Aqua regia. Aqua regia is a mixture of concentrated nitric acid and concentrated HCl. 1 part concentrated nitric acid and 3 parts concentrated hydrochloric acid. Concentrated nitric acid and concentrated hydrochloric acid are in the ratio of 1:3. Aqua regia can dissolve the metals like platinum and gold also. These metals do not dissolve in any of the acids. But in the aqua regia, which is a mixture of 2 acids, concentrated nitric acid and concentrated HCl, these 2 metals dissolve. Now, aqua regia is also highly corrosive. It corrodes various objects and metal objects, wood objects or any clothes, and it is a fuming liquid. How do metals react with the solutions of other metal salts? For studying this property, an activity will be performed by taking 2 test tubes. In one test tube, iron nail is taken and it is dipped in copper sulphate solution, which is blue in color, whereas in the other test tube a copper nail is taken and it is dipped in FeSO4 solution. The color is green. Now, keep it aside for some hours and then observe the changes. You will find that in the case of the iron nail surface is covered by a reddish brown layer and the color of the copper sulphate solution is also little bit faded, whereas there is no change in the other test tube, no reaction has occurred. Do you know why? You have already studied about it, think over it, why this has happened. Let us discuss a general reaction. First of all, metal A has reacted with salt solution of metal B to form salt solution of metal A plus metal B. Now, when this reaction occurs, think what conclusion you can draw. Very clear it is that metal A has displaced metal B from its salt solution. That is, metal A is more reactive than metal B. So, when this reaction has occurred, in this particular case, what will form? You can now write the equation FeSO4 and copper has formed. The solution of ferrous sulphate is green in color, so light green color will be obtained, and you will find that the iron nail, the outer surface of iron nail has become reddish brown in color due to the deposition of copper metal. It clearly shows that iron is more reactive than copper. A displacement reaction has occurred. You have studied it earlier also in the previous chapter, that a more reactive metal displaces a less reactive metal from its salt solution. Now, in this case, as you know, copper is less reactive than ferrous and iron, no reaction will occur. If this reaction, if this activity is performed, copper nail or copper object is placed in silver nitrate solution, will the reaction occur? Think over it. In this particular case, the reaction will occur and copper nitrate will form and greyish white silver will deposit on the surface of copper. What does it show? It shows that copper is less reactive than silver. So, on the basis of displacement reaction, we come to know about the metals. How much reactive one metal is than the other. We know about the reactivity of the various metals, on the basis of which a reactivity series can be made. Now, what is reactivity series? This also you have studied earlier. It is the arrangement of metals in decreasing order of their reactivity. So, metals when they are arranged like this forms a reactivity series. Potassium is the most reactive metal and gold is the least reactive metal. So, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, all are more reactive than hydrogen, and all other metals like copper, mercury, silver and gold are less reactive than hydrogen. So, this is the reactivity series. At the top are the most reactive metals and at the bottom are the least reactive metals. How do metals and non-metals react? We have studied earlier the reaction of metals with various reagents, and now we will study how metals and non-metals react with each other. The question arises, why do metals and non-metals react, or in fact we can say why do elements react? To understand this, let us study first of all the table given here. We should know about noble gases, metals and non-metals, their electronic configuration, which will tell us that what is the reason behind metals and non-metals to react. Now, as you know, noble gases are unreactive, they are stable, they have stable configuration, electronic configuration, their outermost shell is complete. All the noble gases have either 2 electrons in the outermost shell like helium, or 8 electrons in the outermost shell which is called valency shell, like all other gases like neon, argon, krypton, xenon, radon. So, let us first of all study why noble gases are inert in nature, why do noble gases do not react. In fact, noble gases do not react because they already have stable electronic configuration. So, let us study the electronic configuration of some of the noble gases. Helium atomic number is 2 and it has only one shell in which it has 2 electrons. It has 2 electrons in the outermost shell and this is a stable configuration. This is also inert gas configuration, it is a inert gas, unreactive. Neon has atomic number 10, that is it has 10 number of electrons. Atomic number, as you know, is the number of protons, and in a neutral atom the number of protons and number of electrons are equal. So, from atomic number we come to know about the number of protons which are equal to number of electrons in a neutral atom. and so we come to know about the number of electrons in an atom, and we can write the electronic configuration. So, neon has total 10 electrons and it has 2 shells, 2 8 is the electronic configuration, 8 electrons in the outermost shell. This is a stable electronic configuration, that is why it is inert in nature. Similarly, argon has 18 electrons, so its electronic configuration is 2 8 8. Argon is also inert in nature, chemically inactive. Now, let us study the electronic configuration of metals and nonmetals. Then we will come to know why metals and nonmetals react. Sodium has atomic number 11, it means it has 11 protons and 11 electrons. So, its electronic configuration is 281. So, you can see very well its outermost shell or valency shell is not complete, it has 1 electron in the outermost shell. Magnesium has 12 electrons, its electronic configuration is 282, it has 2 valency electrons, that means 2 electrons in the outermost shell or the valency shell. Come to aluminium, its electronic configuration is 283, 3 valency electrons. This is also not having a stable electronic configuration. Now, let us take the case of potassium, which has 19 electrons. It has 4 shells. Its electronic configuration is 2881. Here also potassium atom has 1 valency electron, outermost shell has 1 electron. Calcium has 20 electrons and its electronic configuration is 2882. So, all the metals do not have stable electronic configuration. So, what do we conclude from this? That metals react to attain inert gas configuration by losing the electrons. If they lose the electrons from the outermost shell to react, they will attain inert gas configuration or stable configuration or noble gases configuration, because inert gases are also called noble gases because they are inert in nature, and noble gases, all noble gases are inert in nature. Let us take the case of nonmetals. Nitrogen has 7 electrons, so its electronic configuration is 2 5. Oxygen has 8 total electrons, electronic configuration is 2 6. Fluorine has 9, electronic configuration is 2 7. Phosphorus 15, its electronic configuration is 285. Sulfur has 16 electrons, it has 286, and chlorine 287. In all these nonmetals, nitrogen has 5 electrons in the outermost shell. To attain inert gas configuration, it needs 3 more electrons. Oxygen has 6 electrons in the outermost shell, its outer shell is not complete. To attain a state of octet, octet also means having 8 electrons in the outermost shell, and if there are 2 electrons in the outermost and the only shell, this is called duplet. So, to complete the octet, or we can say to complete the inert gas configuration, oxygen also needs 2 electrons. Same is the case with all. Fluorine also has 1 electron less, phosphorus also has 3 electrons less, sulfur also has 2 electrons less, chlorine also has 1 electrons less. Because why we are saying less? Because these nonmetals cannot lose so many electrons to complete either their duplet or octet. So, we can arrive at the conclusion that metals and non-metals react in order to complete their duplet or to complete their octet, to attain inert gas configuration, to have a noble gas configuration, a stable configuration. Now, let us take the case of a metal, sodium. Sodium, as you have seen, it has one valency electron. We can represent sodium atom by electron dot structure, which is called electron dot representation of an atom. Electron dot structure is written by writing the number of valency electrons on the symbol in the form of dots. As you know, sodium has one valency electron, so one dot is made on the symbol of sodium. Sodium, if sodium loses one electron, it will attain inert gas configuration, right. So, here it is 281. After losing one electron, it attains the configuration of a noble gas. But by losing one electron, it also gains a unit positive charge, because number of electrons are less now and number of protons are same, that is 11. Number of electrons are 10. Now, chlorine atom, its electronic configuration is 287. So, it has 7 valency electrons. Here also we can represent 7 valency electrons with the help of dots on the symbol, but just for differentiation we make these as the cross. These crosses are showing the number of electrons. So, there are 7 valency electrons. This electron lost by sodium atom is gained by this minus sign to show that electron is negatively charged. So, by gaining this electron, its electronic configuration like this. This dot represents the electron which has been gained by chlorine atom. This electron is lost by the sodium atom, right. What is the electronic configuration of chloride ion? Now, it is chloride ion, and this is of course sodium ion. Chloride ion has attained the configuration of argon, inert gas argon, noble gas argon, and sodium ion has attained the configuration of neon gas. Now, because the number of electrons are now more, chloride ion also gets a unit negative charge. So, when these oppositely charged ions, they come close to each other, they are attracted strongly by, they are held together strongly by very strong electrostatic force of attraction, and they form sodium chloride. Sodium chloride is not a molecule. In fact, sodium chloride has oppositely charged ions, oppositely charged sodium ions and chloride ions, which are held together by strong electrostatic forces of attraction. So, we can now write the whole equation. This electron lost by gained by chlorine atom, and we have now sodium chloride crystal in which positively charged sodium ions and negatively charged chloride ions are held together by strong electrostatic forces of attraction. So, this is positively charged sodium ion and this is negatively charged chloride ion. We can also discuss the case of MgCl2, magnesium chloride. Magnesium, you have seen earlier it has 2 valency electrons. By losing these 2 electrons, it also attains neon gas configuration and becomes stable and gains 2 plus charge, whereas 2 chloride ions lose 2 electrons and form not lose, but gain 2 electrons and form 2 chloride ions. So, now we can see this. Magnesium has 2 electrons, 2 valency electrons, and chlorine atom has 7 valency electrons. 1 electron is gained by one chlorine atom and other electron is gained by other chlorine atom. So, magnesium forms magnesium ion having 2 plus charge and 2 chloride ions are formed. So, these magnesium ions and chloride ions, they are held together by strong electrostatic forces of attraction. Now, there is a negative charge here and there is a 2 positive charge here, right. Now, this compound NaCl as well as MgCl2 are called ionic compounds. Ionic compounds are formed by the transfer of electron from one atom to another. When the compounds are formed by the transfer of one electron or one or more electrons from one atom to another, ionic compounds are formed. NaCl, MgCl2, these are 2 very good examples of ionic compounds. You can you can find about some more ionic compounds and write down the electron dot structure and see how they are formed. By the metals will lose the electrons, how do the metals lose electrons, and how do non-metals gain the electrons to form the negatively charged ions. Now, let us discuss the properties of ionic compounds. Ionic compounds are generally crystalline solids. Generally, ionic compounds are hard and solid, crystalline solids, because of the fact that oppositely charged ions are packed together with strong electrostatic forces of attraction. That is why ionic compounds are solid and they are brittle, that is, they easily break on being hammered. To study the next property, an activity can be performed. Take a spatula and take any ionic compound, say NaCl, on the spatula and heat it over the flame of Bunsen burner. It is found that after strong heating for a long time, prolonged heating, only sodium chloride melts. It has a very high melting point, and this is the case for all the ionic compounds, that all the ionic compounds have very high melting and boiling points. The reason is again the same, that is, the oppositely charged ions, that is positively charged ions and negatively charged ions, they are held together by strong electrostatic forces of attraction, and a lot of energy is required to separate them, to melt them. To melt the solid, to separate the ions, a lot of energy is required. Another property is solubility. Now, this also activity can be performed in the lab. Different ionic compounds are taken, like NaCl, KCl, MgCl2, and their solubility is seen in water and also in any organic solvent like alcohol or ether which is available in the lab. It will be found that ionic compounds are soluble in water, but insoluble in the organic solvents like alcohol and ether. Even kerosene and petrol are organic solvents. Ionic compounds are insoluble in kerosene and petrol also, and alcohol and ether. To see the next property, an activity can be performed in the lab. In a beaker, a solution of ionic compound is taken in water, like let us say NaCl solution. Now, sodium chloride is a ionic compound and it will readily dissolve in water. Then two graphite electrodes are dipped in water, or they are immersed in the salt solution and connected to a battery. And a bulb is also connected, and this is the switch. When the circuit is complete, it is found that the bulb glows. What does it show? It shows that when NaCl is dissolved in water, sodium ions and chloride ions separate and allow the current to pass through the solution. Sodium chloride in the solid state does not conduct the electric current. In the molten state also, what happens? In the molten state also, sodium ions and chloride ions are separated and will allow the current to pass through them. So, ionic compounds are good conductors of electricity in the solution form when dissolved in water or in the molten state, because in the solution form also and in the molten state also ionic compound exists as positively charged and negatively charged ions, and they conduct the electric current.